How deep can ground-penetrating radar see? Have you ever wondered how archaeologists can find hidden structures without digging? Ground-penetrating radar is a fascinating tool that helps them see beneath the surface. So, just how deep can this technology actually see? The depth capabilities of ground-penetrating radar can vary quite a bit based on several factors. Typically, in archaeological contexts, it can penetrate anywhere from 0.5 meters to 5 meters. However, under ideal conditions, it can go even deeper. One of the key factors affecting depth is soil composition. For instance, dry and sandy soils allow for deeper penetration, sometimes exceeding 5 meters. On the other hand, clay-rich or waterlogged soils can limit the depth to less than 1 meter due to how they absorb radar signals. This means that the type of ground being scanned plays a significant role in what can be detected. Another important factor is the frequency of the radar antenna being used. Lower frequencies, ranging from 100 to 400 MHz, are better for depth but sacrifice detail. In contrast, higher frequencies, such as 900 MHz to 2.5 GHz, provide finer details but are effective only at shallower depths, usually under 1 meter. The size of the target also matters. Larger structures like walls or foundations reflected radar signals more clearly from greater depths than smaller artifacts. This means that if archaeologists are searching for significant structures, they may have better luck than if they are looking for tiny items. Ground-penetrating radar is particularly useful in archaeological applications. It generates three-dimensional subsurface maps, allowing archaeologists to identify buried structures, graves, or artifacts without the need for excavation. This capability helps them plan their digs more effectively by revealing stratigraphic layers and potential risks, such as voids or unstable ground. Before using ground-penetrating radar, site preparation is essential. Historical maps and surface surveys can greatly improve the interpretation of radar data. By narrowing down target areas, archaeologists can focus their efforts more efficiently. Data interpretation is another critical step. Depth calibration often requires comparing radar profiles with known soil layers or test pits to ensure accuracy. However, there are limitations to consider. Rocky terrain or mixed sediments can scatter radar signals, which reduces clarity and makes it harder to interpret the data accurately. In terms of stratigraphic excavation, ground-penetrating radar complements this technique by visualizing soil layers and disturbances. Depth slices from the radar can correlate with archaeological layers, guiding precise trench placement to preserve the context of the findings. For example, a team investigating a Roman settlement might use 400 MHz antennas to locate villa foundations at depths of 2 to 3 meters. After identifying these larger structures, they could switch to high-frequency antennas to map nearby roadways or drainage systems at shallower depths. While ground-penetrating radar cannot replace traditional excavation methods, it minimizes destructive testing and helps prioritize areas with the highest potential for discovery. This makes it a vital tool in modern archaeological practice.